In this example, we'll use Excel's Analytic Solver platform to run the k-nearest neighbor data mining technique to make predictions about employee success. Daniel Lara, a human resources manager at a large tech consulting firm, has been reading about using analytics to predict the success of the new employees. With the fast-changing nature of the tech industry, some employees have had difficulties staying current in their field and have missed the opportunity to be promoted into a management position. Daniel is particularly interested in whether or not a new employee is likely to be promoted into a management role after 10 years with the company. In the data file, he gathers information on 300 current employees who have worked for the firm for at least 10 years. The information was based on the job application that the employees provided when they originally applied for the job at the time. For each employee, the following variables are listed. Promoted, 0 indicating they have not been promoted, a 1 indicating they have been promoted. Their college GPA at the time of graduation. Sports indicates the number of sports or athletic activities they were involved with during college. And then leadership indicates the number of leadership roles they served in college through student organizations. So we'll develop the k-nearest neighbor model using the variables leadership, sports, and GPA to determine whether a new employee will be promoted or not. And we'll use our model to score 6 new records, or we'll take these 6 new employees based on their GPA, the number of sports they were involved with, and the number of leadership positions they held, and score them to predict whether they will be promoted or not, based on the model we create with this past data. Remember, k-nearest neighbor, or KNN, looks at characteristics and compares them to the characteristics of its nearest neighbor. The majority vote determines the outcome, whether the employee is promoted or not. To start, click on Data Science. And then we first want to partition the data before we even run the k-nearest neighbor analysis. In the problem, they tell us to partition the data into 50% training, 30% validation, and 20% test. This means we'll split the 300 records by 50% to train the model or create the model based on those 50% records. Then we'll use the 30% to validate the model to make sure it's working correctly, and then the remaining 20% will test it. And we'll assess the accuracy and misclassification at each step. So let's partition our full data set of 300 records. The worksheet should already come up, and the data should automatically be selected. If not, make sure A1 through D301 is selected. The first row contains headers because that's the text or labels for the variables. And we're going to select all 4 of these variables and then put them into the selected variables box. It's going to randomly partition these, so pick up rows randomly can be left as is. Set seed is simply a random number to start this. If you use 1, 2, 3, 4, 5, you'll get the same results as I do. So leave that as is, but you can always change that if needed. Rather than automatic percentages, we are going to change this to specified percentages, and it defaults to that 50, 30, 20 split that's defined in the problem. Click OK. And we now have a new tab, STD Partition. And if we look at the partition summary, it tells us that there are 150 records in the training data set, 90 in the validation set, and 60 in the testing set. If we want to look at the actual records, we can view the partitioned data there. We're now ready to run the k-nearest neighbor analysis. So on this STD partition sheet, go back up to Data Science, and we're going to select the Classify drop-down menu because this is a classification technique. We want to classify a new employee as being promoted or not promoted. From this list, select k-nearest neighbors. The output variable is what we're trying to predict, and that's whether or not an employee will be promoted. So select promoted and put it into the output variable. The variables we're using to make this prediction are GPA, sports, and leadership. Select those three and put them into the selected variables. We can leave the other defaults as is. The number of classes refers to the number of classes within promoted. It's a 0 or a 1, 2 classes. And the success class is a 1 indicating they have been promoted, and that is considered a success. Go ahead and click on Next. Here's where we determine the value of K. Rather than selecting K equals 2 or K equals 5, we're going to let Analytic Solver run this model with different values of K from 1 to 10, and we'll let it determine what's the best value of K. So we're going to select Search 1 through K, and we're going to let it search from 1 all the way up to 10. And it'll tell us what is the best value of K. We're going to select Rescale Data, check Rescale Data, and leave it on Standardization. Then click on Done. Click on the Next button. Make sure Summary Report is selected for training dataset, validation data, and test data. And we also want a lift chart. Recall that we have the 6 new employees that we want to test with this model. This is where we'll tell Excel to score new data. So score new data in worksheet, go ahead and put a check in that. That new data is in HR_score. So from STD partition, make sure we select the correct worksheet. A1 through C7 are those new records. The first row contains headers. These are the variables in my model. These are the new variables I want to score, and we're just going to select Match by Name, so it matches GPA to GPA, sports to sports. Click on Next, and click Finish. We now have several new tabs below that we'll review together. The first is the KNN output. This one gives us a summary of what Excel has done. We'll look at the search log, and it gives us the misclassification rate for each level of K. So it runs the model with K equal to 1, the misclassification is 21%. Then it runs with K equal to 2, looking at the 2 closest neighbors, misclassification is 22. We obviously want the lowest misclassification rate, and it tells us that K equal to 8 returns the lowest misclassification rate of 18.88%. So K equal to 8 is the optimal K level. This tab shows similar results for the training data set. It shows us the confusion matrix with the actual counts, as well as the percentages. And it gives us those performance metrics such as accuracy, specificity, sensitivity, and precision. If we look at the validation score tab, it gives us the same information, this time for the validation data set. We can see that the misclassification rate for the validation data set was 18.88%. Applying our model to the test data partition, we can see how the performance really did. 75% accurate. 75% accuracy means overall how often were we right. The specificity of 65% tells us how good are we at predicting who won't be promoted. Sensitivity tells us how good are we at predicting who will be promoted. Let's skip to the KNN New Score tab. This is the output for Excel scoring those 6 new records, or those new employees, and determining whether they'll be promoted or not. The prediction is listed in column D, 0 indicating they won't be promoted based on their GPA, sports, and leadership positions, 1 indicating they will be promoted, and the associated probabilities with those. Let's take a look at the lift charts. Click on Test Lift Chart, and then at the top, click on Charts. It'll automatically create a few charts that we'll look at. Let's start with the ROC chart. The ROC curve helps us visualize the trade-off between the model's ability to correctly identify promoted employees, true positive rate or sensitivity, and its tendency to misclassify non-promoted employees as promoted or false positive rates. The x-axis is the false positive rate. The y-axis is the true positive rate. The diagonal red line represents a random model's performance, so just guessing by chance. And our KNN model is the blue line. Because it's above the diagonal line, it means it's performing better than random guessing. The further the curve is away from the diagonal, the better. The AUC, or the area under the curve, is a single number summarizing the ROC curve's performance. The higher the AUC, closer to 1, indicates a better model. We can find the AUC, or the area, from the data table. So let's move this out of the way. And if we scroll down, the AUC is 0.7475. Or the area under the blue curve is 0.7475. That means the model has about a 75% chance of distinguishing between a randomly chosen promoted employee and a randomly chosen non-promoted employee. Let's look at the decile chart. The decile chart is similar to the lift chart, but provides a more granular view of the model's performance. It breaks down the data into 10 equal groups, or deciles, based on the predicted probability of promotion. The x-axis represents the deciles from the highest probability of promotion to the lowest probability of promotion, and the y-axis shows the lift, which, as in the lift chart, is the ratio of the proportion of promoted employees found in each decile to the proportion we'd expect to find by chance. The baseline is the 1.0, or what we'd expect if we randomly selected employees. Anything above the baseline indicates our model is doing better than random guessing within that decile. So higher bars indicate better performance. We can find the exact height of these bars from the output. For example, if we wanted to know the height of this first decile, this first bar, we would look at the decile chart data, and the first decile is 1.25. So this first bar, the height of it is 1.25.